velocity of sound is calculated or determined by a method called resonating air column method. Let us observe this experiment. Take a long glass jar of a diameter about 30 centimeters and height 50 centimeters. Pour water into jar about 3/4 level. Take another glass tube T of length 40 centimeters and diameter about 3 centimeters, which both the ends are open. Fix the tube to a clamp or a stand. Immerse the tube T in the water of the jar J. The air inside T will be confined to the length of the tube and is said to form an air column. This air column will have a length L above the level of water in the tube T. The air column formed in the tube T has its own natural frequency. With the change in the length of this air column, its natural frequency of vibration also changes. When the natural frequency of this air column coincides with the frequency of the vibrating tuning fork, resonance takes place. Such an air column is called a resonating air column. The water surface in the tube T acts as a rigid end. The other end of the T is open. Such a tube T is called a closed end tube. When the first loud sound is heard, the length of air column is observed to be L1 centimeters, where a longitudinal standing wave is represented. Here, there is a node at the bottom of the column. There is an antinode on the top of the column. There are no other nodes or antinodes between the two ends of this air column. Since a node and next antinode are separated by a distance lambda by 4, so L1 centimeter is equal to lambda by 4. When the second loud sound is heard, the length of air column is observed to be L2 centimeters. At least one node and one antinode between the two ends of air column is being observed. This means the length of air column L2 is equal to 3 lambda by 4. The length of second air column L2 is 3 lambda by 4. We see that L2 is equal to 3 lambda by 4. If we subtract L2 minus L1, that is 3 lambda by 4 minus lambda by 4, we get lambda by 2. From this, the wavelength lambda is equal to 2 into L2 minus L1. As we know, velocity of wave is determined by V is equal to nu lambda. By substituting the value of lambda in the equation, we get velocity V is equal to 2 nu into L2 minus L1. In the above equation, nu is the frequency of the tuning fork, L2 is the length of second air column, L1 is the length of the first air column. In this way, we can find out the velocity of sound in air by a method called resonating air column method.